Way 26 deals with electron movement. Whenever electrons from an atom absorb energy in the form of light or fire, they become excited. And they do this by going from a lower energy state to a higher energy state. Whenever those electrons come back down, they release the energy that they absorbed in the form of light. And this is what causes fireworks to appear so beautifully. Those elements, electrons, are coming down from an excited state back to a lower energy state. This also happens in the case of fluorescent light, where we're passing an electric current through a gas, and those elements, electrons, those atoms are getting excited and coming back down to a lower energy state and releasing light. So whenever you get questions on this, know that all energy in the form of light comes from electrons moving from an excited state to a lower energy state or the ground state. So let's try a problem. It says the bright line spectra observed in a spectroscope for 3 elements and a mixture of two of these elements are represented in the diagram below. Describe in terms of both electrons and energy state how light represented by the spectral lines is produced. So if you remember the way, all these questions will become considerably easy. If you simply write energy in the form of light is produced as electrons in an excited state returned to the ground state, you will have sufficiently answered this question. Please note that anytime you see an in terms of question, you must mention the terms mentioned in the problem. So it asks us to mention electrons and energy states. We have to say something about electrons and energy states. So electrons and excited states are both mentioned in the problem. Let's try another problem. In terms of electrons and energy states, how is the light emitted by excited atoms produced? Again, same problem, same answer. Energy in the form of light is produced as electrons in an excited energy state return back to the ground state. Every time electrons come down, they release energy or emit energy in the form of light. Which electron transition in an excited atom results in a release of energy? Again, in order to release energy, we go from excited or higher energy state to a lower energy state. The only one that shows a decrease in energy is answer choice 4. So 4 is correct. All the others show a lower to a higher energy state. So the answer is 4. Compare the energy of an electron in the first shell of cadmium atom to the energy of an electron in the third shell of the same atom. So how do the energies compare? You should have said that the energy in an electron in the first shell is lower to the energy of an electron in the third shell. Those shells indicate the energy level. The higher the shell, the higher the energy level. Which change occurs when an atom in an excited state returns to the ground state? Okay, you should have said answer choice 1, energy is emitted or released. Base your answer to the question on the following passage. Fireworks that contain metallic salts such as sodium, strontium, and barium can generate bright colors. A technician investigates what colors are produced by the metallic salts by performing flame tests. During a flame test, a metallic salt is heated in the flame of a gas burner. Each metallic salt emits a characteristic colored light in the flame. Explain in terms of electrons how a strontium salt emits colored light. Again, you must mention electrons in your answer. You should have said energy in the form of light is produced as electrons return from an excited energy state to the ground state. And again, if your answer did not contain electrons in the answer, then it would be counted wrong. Describe in terms of both electrons and energy states how the light represented by the spectral lines is produced. Again, same question, same answer. It's just asked a different way. Energy in the form of light is produced as electrons in an excited energy state return to a lower state or ground state. And again, your answer had to contain the word electrons and energy state in order to be correct. During a flame test, the lithium salt produces a characteristic red flame. The red color is produced when electrons in excited lithium atoms Again, all this red color and light is produced when electrons move from a higher energy state to a lower energy state. So answer choice 3 is correct. Last problem. During a flame test, ions of a specific metal are heated in the flame of a gas burner. A characteristic color of light is emitted by these ions in the flame when the electrons emit energy as they return to lower energy levels. So if you remember that all light produced from a burning element, such as during a flame or whenever we pass energy to it, all that light comes from excited electrons returning from a higher energy state back to the lower energy state or the ground state. Hopefully this was helpful, and thank you for watching.